Big applause for Slobodan and his new book, please.
Thank you.
I'm sure he will mention it today, your new book. And he will talk about why your future apps will be serverless.
Exactly.
Exactly.
Thanks.
Here's your time.
Thank you. So, hello everyone. It's a bit weird for me to speak in English in Serbia, but let's do this. So, thank you for coming here. I know that in the other track there's a really interesting talk right now. I'll try to make this one fun, because it's the last talk, of course, and I'm pretty sure you're tired. So, before we begin, let me just first test how fast do they track me. No? Oh, they're cool. So, what's this talk about? I'm talking about serverless, and you as a PHP developers mostly use servers and everything, and you do backend. So maybe it sounds like I'm a salesman that is trying to sell automated car, self-driving car to a taxi driver or something like that. But no, I'm not here to sell you anything. I really don't care if you will try serverless or not, but it works for me. It works for a lot of other people that I talk to. So I just want to present you something that you can try and use. And also, it's not self-driving car, it's something that can help you in your development. So let's start. First, I'm Slobodan Stojanovic. I am CTO and partner in Cloud Horizon, small Serbian-Canadian company. We're doing a lot of PHP, we're doing a lot of other things, including JavaScript and some Java and things like that. We also have some, we're doing services for some clients, and we are also doing some of our small products. And we, maybe 2 years ago, started using serverless on some of those products. We're not using serverless for everything, and you shouldn't probably use serverless for everything. And I'm also co-author of serverless apps with Node and Claudia.js book published by many publications. I wrote that book with my friend Alexander Simovic, and we'll talk about the book a bit later. You can follow me on Twitter, and from time to time, I'm writing about serverless and other things with my friend Alexander on effortless-serverless.com. And before we begin, I have a few short questions. First one is, who heard about serverless? Perfect. Who used serverless? Okay, perfect. And one more question, who's using some big frameworks such as Laravel or Symfony or something like that? Okay, perfect. So let's start with more questions. So, do you know the feeling when you work on some complex problem for a few days or even few weeks, and then one morning you just fix that problem in 5 minutes with a coffee, or you just find out how to solve something during your drive to your job or something like that? I really love that feeling. That's something that why I love working as a software engineer. It's like I want to tackle complex problems and work on them. So I guess most of you know that feeling. But also, do you know the feeling when you find some new tool or framework, and then you're excited about that? And then after some time, you manage to implement that into your into product that you're working on. And at least for me, that feels really nice and makes me happy. Also, I love the feeling when I receive some nice feedback from my customer, either end customer for the product that I'm working on, or my client, or anyone else that is using my product, when someone tells me that they're happy using that tool that I built. I'm pretty sure you also love the feeling, as I do, when you're working on some really, really complex problems in an awesome team, when you're surrounded with smart people, just focusing on handling something really, really hard and complex. I enjoy doing that. Finally, I'm pretty sure you like this, because I really, really like this. This is probably my most favorite thing in programming. It's when I have some new idea, maybe sometimes it's really small or some big idea or something like that, and I'm not able to stop coding and working even during the night and during the weekends, and that's something that why I love programming. And for me, that's a good part of web development. And I don't think you hear the sound, but fortunately I tried. So, but also, there are some things that I really don't like. For example, when you're spending, did you ever did something like this, spending like few hours or even few days to set up something like Vagrant or Homestead on some project that you jumped in, or maybe you help your colleague to do that, and something is just not working, and you just want to jump in and work on the problem that you have, but you need to solve that boring thing with the infrastructure and everything. Or, for example, when you need to set a dev server and you don't have a DevOps team or anyone else, and you really need to do that, but you need to spend a few hours to set everything up, and you're trying to remember where did you bookmark that article that explained how to do everything perfectly well. And for me, that's really boring. Or, for example, when you have few servers in production, and again, you don't have DevOps team or something like that, so there are some new security patches and things like that, then you need to Google how to do everything and go to each server and do that, and that's something that I really, really don't like. Or maybe when you're using Docker and you're really, really happy with Docker and some other tool, but then you have some specific situation that is really hard for you to figure out, and Stack Overflow is not helping because it's specific for your project. And then you're spending hours and hours on trying to figure that out. It's a nice feeling when you fix that. But again, it's not something that I enjoy. Or do you know the feeling when you want to refactor something that you see that needs to be refactored, but then you try to tell that to your boss or your client or anyone else who is dealing with the business part. And of course, they're not happy. They're allergic to the word refactoring. I'm pretty sure everyone had the same thing. So those are the bad parts of software development for me. It's something that I need to do, but I really don't enjoy. And also, there are some things that are even worse than that. For example, you worked hard on a demo or something like that for weeks or something like that, and then you just want to deploy everything before showing that to whoever you need to show, and something is not working in production on a server. And then you need to figure out what's happening, but you need to do that fast, and you're already tired. That's something that I really, really don't enjoy. Or maybe during some important event or advertising campaign, your server just breaks down, and then you have your boss or your client just pushing you to solve the problem faster, and you're already tired and work very fast and trying to figure out what's happening. And that's definitely something that I don't enjoy. Or, for example, what happened to me once, we had a few WordPress sites, and I wasn't even aware of that one. And I was on my way to Niche for some conference, and then someone from the company called me and told me that the new website for a client that they set up was hacked by Turkish hackers. And then in the middle of a highway, I tried to figure out what happened, and in the end, someone just left the password admin, which is unfortunate, but yeah, it happens. Or for me, the worst part is, for example, when you're spending a good time with, come on. Sorry. The worst part is probably when you're spending a nice time with your friends and family, or during the weekend, or you went to a vacation, your deserved vacation after a few months or a few years, and then there's an issue in production that you need to stop doing everything and focus on that. And of course, that's an ugly part of web development, at least for me. So, is our job to do those things? What's our job in the end? Is it to write the code? Is it to manage the servers and things like that? Well, I hope not. So if someone tells you do something, I don't think our job is just to jump in and start typing and try to do exactly what someone said to do. And as I said, I hope that's not our job. For me, our job is to try to understand the business and then to use technology to empower that and to apply those things with the technology. And of course, in that situation, it's a win-win situation. Client can be really happy, and you can do very nice things. And as I said, for me, our job should be to understand the business needs, and then probably to write the code, or even not write the code, to do those things and power those things with technology. So how did we end up with the situation that we need to manage servers and do the things that we really don't like? Or what was the evolution of compute and everything to this day? So everything started long time ago with genesis of compute and applications. So for example, some first computers like ENIAC was custom built and everything was custom built and no one else did that before, so even parts and everything was completely custom built just for that machine. And then after some time, compute and applications started to be more and more built, and then we had a genesis of operating systems because they saw that we need something like that. At some point, all three parts, compute and applications and operating system became products, something that you can buy. And when that happened, we had a genesis of good practices, something that we need to do to be able to serve the applications. At some point, for example, when you need to have a data center to handle something, you need to plan in advance how many people will use your application and things like that, because adding new server is not just click on a button or something like that. You need to order that machine needs to arrive, and then you need to set it up and configure and everything. And of course, with all those things, we had a rise of new programming practices and some first custom-built frameworks, because we started mass production of the applications, but we of course need some good practices. What should we do and what shouldn't we do? And of course, they are tied to the architecture that we had at that moment. And then the thing called cloud happened. And yeah, with cloud, some things changed, because it's basically just the evolution of compute from the product to utility to something that everyone can have easily and that is not expensive anymore. So at some point, servers were our pets, but now they're like cattle or something like that. And I guess whoever grew up in Serbia and has grandparents in the countryside knows that it's not good to have a pet pig or something like that, because one day it's not there anymore. So the same thing happened with the cloud. And as servers are not our pets anymore, we need new architectural practices, how to handle those things, because we don't need to plan some things in advance anymore, because having a new server is quite easy now, and doing things like that. But we have new problems, and then of course with the new things and new architectural practices, we got the thing called Devops, which is great. It helps us to understand how applications are scaling and to simplify those things that are quite complex for us. But what's next? Can we do something better? Do we all need to become DevOps engineers or something like that? And how can we do something better? And there are people that explains that much better than I do. For example, Simon Wardley explained that perfectly with his talk, Why the Fuss About Serverless, with something he calls Wardley maps. And the Wardley map is something that tries to explain, for example, during the battle or something like that, you have a map, but you need to know where's the position of your enemy and what's the direction that your enemy will go, and some other things. It's the same for business. You should know the map of your business and how things are evolving during the time. So here's the map for the things that I just said a few minutes ago. So let's try to analyze this. First, compute was Genesis, and then it became custom build, and then now, at some point, it became product, something that you can rent. It's a virtual private server. But as you can rent a server, you need some good architecture practices, how to organize that in your application. So practice at that moment was commodity, something that you don't need to buy or do things like that. It's defined already. It's easy to use, something that already exists. Then you have operating system, which is a product, something that you can buy, or I don't know, just get if Linux is free. And then, of course, application or a framework became, again, product, not custom built anymore. You can go and use Laravel or something else. And then, of course, with the framework, you have some set of best practices for that framework or a platform. And finally, you're building the application, which is a product, something that you're selling or something like that. So things are moving. So how everything moves? First, compute is trying to move to utility with cloud, something that everyone can have. But of course, there is some kind of inertia, something that blocks that and tries to push back, because we are used to some things, of course, and our old best practices and things like that. But as we have compute as a commodity, something that everyone can have whenever they want, Then we need a new best practices, which is DevOps. And of course, that tries to push on the side from the product and rental to commodity. And then operating system with servers, you most of the time don't worry anymore about operating systems. It comes with something that you want or whatever. So that's a commodity. And also frameworks and platforms are leaning towards a commodity, something that is there and you can just use. So with those things, if we change just this part and we continue building with the old best practices for our application, we are not really using the things that we have, the new best practices. So some new architectural practices and coding practices are arising. And at the moment, they're completely custom built. And of course, they're leaning slowly to the product, something that we'll just buy or learn how to do. And of course, as all of those things are leaning toward commodity, it's something that someone else can manage for us. For example, cloud provider or something like that. So the only thing we should care about is the top part, our application, how do we code for it, and how we do prepare some things for it. And finally, what framework or platform will we use? And I think this is the answer. This is serverless. Basically, what you see here, it's serverless. But let's try to define serverless, because most of you heard about the buzzword, but not, it was hard to me to understand what exactly is that. So if you try to find a definition, one of the definitions that you'll find is that serverless computing is basically a cloud computing execution model. It's still a cloud, so it's a new just execution model, where cloud provider is dynamically managing allocation of machine resources. So you don't need to worry about memory and things like that anymore. Someone else will do that, or scaling and things like that. And also the other important part of serverless is a pricing model, which is completely different now. You don't pay for reserved capacity anymore. You pay only for used capacity, which is huge impact for the businesses. And let's try to explain what does that mean exactly. Basically, this means that with a serverless application, you pay nothing if no one is using it. It sounds perfect for startups, right? You don't need to pay anything if 0 people are using it. Of course, if you're storing a few terabytes of data, you'll need to pay for that data, of course, because someone will need to store it. But that's not the only benefit of serverless. There are more benefits. For example, auto-scaling. If you have 1 request, so if you have 0 requests, you pay nothing. But then maybe next minute you have 100 requests. It's great because cloud provider, for example, Amazon, Google, or Microsoft, will automatically scale your containers and have like 100 instances for you, and you'll pay just for those execution times. And that's the second benefit. So if you have 100 parallel instances at the moment, you'll pay for those 100 execution times, and that's it. You'll not pay a second later. You'll have 0 instances, and you'll not pay anything for them. Also, you don't need to maintain new servers because someone else will do that. You just need to write some kind of functions and prepare your code. So that's great, at least for me. And it has a short time to market. So when you try to code something, and when you finish something, until the moment someone else can see that, you just need maybe a few minutes or even a few seconds, something like that. It's really easy to push something to production and make it production ready because everything else is completely managed for us. And of course, it's cheap. And how cheap is it? For example, my friend has a service with 400,000 active users, monthly active users, and his cost for AWS is $100 per month. So it's just $100 for 400,000 active users. It's amazing. And the most amazing part of that is that CloudFront, as a front-end cache, is like 60% of that. And Lambda, which is computing part, like on the back end, is just 67 cents for 400,000 active users. That's amazing. And let me tell you why serverless is important, at least for me, because maybe for some other people will not be important. Well, one of the first things why serverless is important for me is because whenever we read about some best practices, we read from big companies such as for example, Netflix or Facebook or Google, and they have really interesting problems, and they're doing great solving them. And I love reading that. But the biggest question for me is, do I have the same problems as Netflix? Am I serving like 100 of millions of video files, and do I need to scale that much or something like that? Well, most of the time on the products that I'm working on, I really don't need to do that. So I would love to use chaos monkeys and do chaos testing and things like that, but most of the time I don't really have time for that, and I don't have enough people to do that, and they have dedicated teams for that, which is great, of course. So should we use the same best practices as some big companies? Well, I would say probably not. We should probably use them as a role models and lean to that, but not really use all those good practices that they use. So what can we do? The thing with serverless that I really love is that it's focused mostly on small and medium applications. It works really well for large applications. Even Netflix is using it. But the biggest benefit of serverless is for startups, for some medium companies, where you have mostly programmers and you don't really have Devops team that will manage the infrastructure and everything. And that's really great for me, because that's the part that is boring for me. I really don't want to manage servers. Even my company is called Cloud Horizon, but we did cloud things a long time ago, and we tried to move from that, because when you're doing cloud things, in zero times, client will come to you and tell you, hey, you did a great job with that server. It works perfectly. Every time when someone comes to you, it's because something is not working. So that's definitely not something that I want to do. But that's not all, of course. There are more benefits of serverless. And for me, it's simplifying my application, because I don't need to write everything. I can just use some services that AWS is providing. I'll show a bit later how do I do that. It allows small teams to build big and really good things. I'll show that a bit later too. You have function isolation, so everything you do is isolated from other users or even other parts of the system. So if you do a mistake with one part of the system, at least you have some isolation, so not everything will go to hell. Also, of course, I'm mentioning this million times, but whoever dealt with scaling issues and things like that knows that this is not fun when you have issues and when you don't know how to do that, as I don't know how to do that. Also, code reusability. That's something that everyone is trying to sell us. But with serverless, it's the first time that I managed to do something like this and really reuse even parts of the application, not just some functions and things like that. And also, this is probably the most important part. It's financial incentive for refactoring. So if you program your application, I'll show you a bit later how do serverless application look like. But with serverless, you're not doing domain-driven development anymore, because you don't need a big domain or something like that. You can focus on processes. And then, because of pricing model and everything, you can see how much each function costs you. And it's really easy to sell to someone that you can show the data with exact numbers, how much some process costs you, and then you can isolate that, refactor that really fast, and compare the prices. So finally, you can show the prices to the business and show them how much it costs before refactoring and how much it costs after refactoring. So it's really easy to sell something like that to business people when they can see the numbers. And everything works like if you have 0 requests, you don't have any functions in any serverless applications that are working. But when you have a lot of requests, everything will just scale horizontally, and you'll have a lot of like Lambda functions or some other serverless parts, and then you'll just serve your customers. And second after that, when each request is finished, your functions will just be turned off, and you'll not pay for them anymore. Also, there's one more thing that I want to tell you, and it's probably not the perfect thing to tell on the backend conference. And that's serverless reduces the amount of backend code, and it reduces it a lot. So I hope no one has X right now, but you can use Twitter to. So I just want to show you a few quotes. It's from few days ago. So Joe Emison is, he's quite famous in serverless community now, but he did many different things. So the quote is like this: he's hiring only front-end developers now, and he's the only DevOps, backend, and mid-tier developer in the last 2 companies that he's working on. And those are not really small companies. And everything just worked fine. And it's even worse now. Just check this. With AppSync, which is one of the services that AWS is providing, it's like GraphQL, serverless GraphQL. He can continue being CTO. He said that he can continue being CTO and serve up to 100 front-end developers as a sole back-end developer. So that's a lot of code that you can just remove. That sounds scary for back-end developers. It's not scary at all. It allows you to focus on most important things and remove things that you really don't need. So I'll stop with quotes. And the question that I have most of the time is, can I just host my own serverless infrastructure instead of going with Amazon because I don't want to have vendor lock-in and things like that? So basically, yes, you can. You can host something, but that stops being serverless anymore. Because, another quote, it's not the bad like the previous one, is that there's an important difference between managed infrastructure and managed compute. And you're not serverless if you don't have managed one of those 2 things. For example, if you host the functions on your own infrastructure, which you can do with OpenVISC and OpenFaaS, those are not serverless functions anymore because you need to manage infrastructure. And also, if you have something like serverless Kubernetes or something like that, it's not serverless anymore. You have to worry about some things in the infrastructure. Serverless is something where you don't need to worry about any of those things. So, as I showed on that map, we need to change some things in order to be able to use this serverless thing. And what do we need to change? And it's easy. We just need to change our mindset, which is probably the hardest thing to do. So this is the quote that I used at the beginning. So when we had a transition to the cloud, we stopped treating our servers as a pets, and we started treating as a cattle, something that you can just buy a lot of them and whatever. But with transition to serverless, it's even worse. You just need to treat your servers as cockroaches or butterflies or something that will live just a few minutes and then you'll crash it. It's okay. That's the thing that we need to do because that will allow us to build completely different systems and have some benefits from serverless. Also, the thing that probably most of the PHP developers don't like is that you cannot use big frameworks anymore because if you try to fit everything into one function, that will just not work that good. And you need to simplify things, and you need to try to move fast and fail fast and test the things, because you can do that. And my friend is calling serverless like process-driven development. So you handle one process in your company and then the other process, and then you can optimize each of them. The other question is, for example, are there any special patterns and anti-patterns in serverless? And the answer is simple. It's a genesis of patterns, anti-patterns. So it means that you can just create your own patterns or anti-patterns, and even many people can start using that. For example, one of the first anti-patterns was server monolith. It's like pushing the huge application inside the Lambda function. That slows down things, and then you cannot have anymore the thing that is like fine. If you do refactoring, you still have one big application, which don't help you much. But there are some companies that build really great products with something like this. So it's not really an anti-pattern that you shouldn't do in any way. Also, there are some first patterns. For example, fan out. It's like you have some serverless function, and you have some big request at the moment. And when you have that big request, instead of just doing that request, and that will probably take minutes to finish or something like that, you can just call your friends that can help you, because only execution of the function will cost you something. And also, it's time-based. So having one function that will work for 2 minutes, it's equal as having, even with the price, like 20 functions that will work for 100 seconds or something like that. So we can just scale everything up, and that's the fan-out pattern, which you can use. And as I said, you can simply create your own patterns and anti-patterns and see what's working for you and what's not working for you. And then maybe some other people will just use your patterns. And I think the most important question is, how does this work in production? So let me show you. Who knows about CodePen? Okay, perfect. So CodePen is, for other people that doesn't know, CodePen is an important site for front-end developers where you can go and write some cool experiments with HTML, CSS, and JavaScript. But you can also use like next version of JavaScript or maybe Sass or something like that. And they then need to convert everything to CSS and JavaScript so they can run that into your browser. So basically, they have a team with mostly front-end developers, and they have just one DevOps person. They have like 2 developers that can work with the backend, but they're mostly Ruby developers. Their backend is and was Ruby on Rails application, quite big application. And they have a lot of preprocessors that needs to be isolated. And they figure out that they need to be isolated because they try to put them on the same machine. For example, something that will convert Sass or less or something like that. But then they realize that their users are really creative, so someone can send a function that will execute some function in the background through Sass, and they can affect the other code and your server. So they need to work with the isolations. And they have a lot of requests. Most of the time, they have like 200,000 requests per hour, which is not the biggest application ever, but the application for one DevOps and a lot of front-end developers, it's quite good. And they have unexpected peaks because you can make some cool pen, which is the name of those experiments, and then someone famous can share it, and that can become really popular really fast, and then a few minutes after that, it can stop being popular or whatever. So they ended up doing something like this. They kept their old infrastructure, so it's a client-side application, which is served through Ruby on Rails, and it's connected to some kind of database. And then, to be able to try to isolate everything, they tried serverless. So instead of using the same server or different server for preprocessors, they had the API gateway on AWS, which is the API layer that serves. It's a serverless API layer that will just scale. Then in the background, they have some Lambda function that will receive everything. So whenever you're using, for example, Sass, and you want Bubble to convert JavaScript code, client will send that to this API. It will pass that to this Lambda function, and then they'll use something that looks like fanout, which will trigger one function for example, Sass, the other function for Babel and Bubble, whatever, ES6 and things like that, and the third function for maybe PUG or HTML processing. And then when those 3 functions are finished, they will return everything back to the user, and you'll be able to see CSS, JavaScript, and that experiment. So it's quite simple. They didn't overcomplicate everything. But the benefits that they had is really short time to market. Whenever they want to deploy a new preprocessor because a new version of Sass or ES6 or whatever, they can just do that in a second. It's really easy for them to deploy that. And their front-end developers build everything. All that layer in the background was built by front-end developers, and they can deploy everything which is production ready and ready for 200,000 requests per hour without DevOps person, with just one command. Also, they have auto-scaling and automatic isolation of everything because everything is completely isolated. Each Lambda function cannot access anything else and even cannot access the system behind. So it's great. And also, their front-end developers now have superpowers that they can even build some back-end systems that can go directly to production. And the most important part of that is that I think 250 million requests per month costs them like a bit more than $1,000, and they didn't optimize anything, and they can decrease that for 2/3. They can end up with like $300 per the infrastructure, which is amazing for me. So that's one of the examples. The other example that I want to show you is a tool that we built a few days ago. It's not a commercial application, it's an open source application, but it's basically, you need to do some kind of error tracking. It's even more important in serverless because everything will just auto-scale, but maybe some part that you're connected to will break after some time. So we built a tool called Désolé, which is basically an open source error tracking for front-end client-side errors. And it's like Sentry or something like that. And most of the time you need to do something, you can go with some SaaS product, but now with GDPR and everything, it's like you need to pick your product and then you need to add that to your policy and everything. And with this, you can do self-hosted solution, which works exactly the same as some other solutions, and it's cheaper. So some of the main benefits were like convenient and secure. You can install it easily and you have everything on your infrastructure on AWS. Then it's cheap and scalable. If you have one error or few thousand errors at the same time, it can handle it. And it's really cheap because you pay just per request. And for example, AWS Lambda costs like 20 cents for 1 million requests. So it's really, really cheap. And first million requests each month are free. So it's even cheaper. And you have some kind of serverless application repository where you can go and click and install everything with one click. And finally, it's GDPR friendly, so you can just send your email to your subscribers. And it looks something like this. So we build a small client-side JavaScript file that you include in your website. And when you click install for that backend application, you get the API gateway, which is auto-scalable. Then you have one Lambda function that handles that request, which is again auto-scalable. And then it just pushed to some simple notification service in AWS. And we did that so you can have, for example, alarms and notifications through CloudWatch. It just connected to this. And you, for example, you can say, if you have more than like 10 fatal errors in 5 minutes, then you can receive an email or something like that. It's the same for S3 for stack traces, so you can do queries with Athena or something like that. And I'm sorry. Also, we have a Pinpoint Dashboard, which gives you a dashboard, which is again free. It's like 10 million events per month are free or something like that. And finally, you can publish your own parts. For example, we have Elasticsearch, but you can do whatever you want. Just subscribe here and do whatever you want. And the most important, the most amazing part with this is that everything was built with 3 of us in just 2 days. It's like 3 days, but it's like part-time work during the week. So something that looks like Sentry and works like Sentry was built in 3 days. It's really, really simple and fast when you know what you're doing. And the last demo that, actually the last case study that I want to present you is our in-company startup called Vacation Tracker Bot. And it's basically a chatbot that allows you to, ask for a vacation in your company, and then your boss can or manager can approve that vacation request and things like that. And basically we have small in-company startup where one developer is dedicated to that and the other developer helps from time to time, but he helped maybe for a few weeks. It's basically a Slack chatbot. Then you have Angular application and you have a full API that handles many things. And the current cost of infrastructure is $0. Of course, we have like 30 companies that are using it right now. It looks something like this. It's more complex than this, but I try to simplify it. For example, from Slack, you send some, whenever you send some command, it hits the API gateway, and then it answers with some of those Lambda functions that handle Slack events or /commands. With your browser, you load your website from S3. It has cache and SSL from CloudFront. And then also the Angular dashboard is served from here. Then Angular dashboard is using the same API for, actually API gateway for some Lambda functions that are API and connects to different databases. We have Mongo and DynamoDB at the moment. And also for Stripe, we have a set of functions here that are connected to Stripe. And finally, whenever we want to notify someone that, for example, who will be off next week or something like that, we have CloudWatch events that hits another Lambda function that sends a message to Slack. And it's quite easy when you split everything. For example, this part here, it's a lot of different small functions that handles complete Stripe billing with webhooks and everything. And we created a small application for serverless repository that will open source in a few days. So on our next product, we can just install this with one click. And here are some benefits that we had. So really small team, when you want to test something in a company without some, for example, VC money or something like that, you can do that easily with this. We have reusable parts, so subscription part and some other parts are just click to install for our next product that we are working on right now. We have a short time to market because everything we do, we can just publish, and there are small parts of the application. You can just easily publish something to test server, and then QA tests everything, and when it's approved, you can just promote that Lambda function as a production version. And it's cheap because for now it costs us $0. And it's easy to refactor and do A/B tests and things like that because everything is isolated. So we were able to change some parts of the system really easy without affecting anything. And the result looks something like this. So whenever you do /vacation, is that working? Yeah. Whenever you do /vacation, inside your Slack, you'll get some kind of buttons, and you can request your vacation. And when you request vacation, you can pick the dates. You have a small calendar inside. And when you do that, your admin will receive some notification. So everything is events. Many people talked about event sourcing today and yesterday. So it's basically similar to that. And that's it for case studies. The next part, we have 10 more minutes. So do you want to see how does that work in code? Okay, let's do this. And sorry, I have a backup slide, of course, because demo will probably fail. I'm kidding, I hope not. So let me just connect to my Wi-Fi. And so in 10 minutes, I can do many things, but I'll just deploy the small function into AWS Lambda and things like that, so we can test that in production. Just a second, give me a second. Well, second passed. Oh, airplane mode. That explains everything. Yeah, I have that, but I don't have a password. But I can connect to this. It should be fast. Oh. Jel? Super. Ajde konektovao sam se već. So sorry for Serbian. I'll mirror my display. Can you see this? Let's try to. Tell me when you can read this. Is it big enough? Okay, perfect. So what I'll do is, first let me show you this is an empty folder. So I'll do npm init, and I'll just answer to yes to everything. So I have package.json, and now I'll just install one thing called Claudia. Claudia is a deployment tool that we are working on, and I'll use right now. It's for Node.js. I'll install a thing called Claudia API Builder and save it as a dependency. It's a Node dependency. Oops. Oh, I don't need sudo. Oh, it's builder. Sorry for typos. So, okay, now I have everything. So I'll create one file which will be called, for example, API.js. In that file, first I like to use strict. It's a very interesting demo, as you can hear. I'll import my API builder. And I'll create an instance of that API builder because it's a class. And then I'll just export that with, yeah, I can do model sports. I'll just export that because Claudia requires that. It will take this file and put inside AWS Lambda and wrap into some other code. So did anyone work with Node.js? One person, two persons, perfect. So it looks similar to Express. I can do something like this and answer, if I want to answer with hello PHP Serbia, I can do just this. So we have one route. And also let's add post route to the same thing. And let's just answer with some, for example, JSON file, which will be hello world, whatever. the most boring demo ever. I'll now use that tool called Claudia, and I'll use create command, which will deploy the API, and I need to set the region. And the region can be, for example, EU Central 1, which is Frankfurt. And then I can also, actually I need also to specify where is my code. And that's API module, and it's called api.js, so I need just to tell API. And because phpsrb probably exists as a name, actually, it probably doesn't. Let's write. Yeah, something is wrong with my code, sorry. Great thing with the, yeah, with live demos. So let's do create again. It's creating some roles for me, so it allows my function to just run this, this code, nothing else. And then it will deploy my code. It will create the API for me. It should take like 30 seconds more, something like that. It takes a bit more because it needs to wait for roles to be propagated and that it can be used. So this is going to new lines because the response is too short, but if I try to copy this right now, if I manage to do that, and go to my browser, and just paste that URL, I got the function in production. And if all of you try to load this function, it will scale and serve hello phpsrb to everyone. So I just deploy something to production that everyone can use. And the even more important thing is if I do something like, for example, fetch, I'll not do that because we don't have enough time. But for example, it already has the cross-origin requests and things like that, so it's ready for production. So that's it. It's that easy to deploy a serverless function. That's the API that can be automatically scalable, and I can delete this slide because I really don't need it anymore. So that was a short code demo. Code demo. It wasn't that fun, but the most important part is that I just deployed something to production in just a few minutes from the start of the project. And that's it for my talk today. I want to mention those few tools that I used. It's Claudia, for example, claudiajs.com. That's a framework that actually not a framework, deployment library that I use to deploy everything. It works just for Node.js. Désolé is the tool that I showed you that for client-side error handling. And if anyone wants to try vacation tracker, you can do that. If you do that in the next month, it will be, you'll get 6 months free because soon we'll go out of beta, and then, I don't know, we have some shorter trial period. Basically, really, really short summary. The thing that I wanted to tell you today is that your developers, you shouldn't be religious about your frameworks and tools. Those are the things that we love and use every day, but that's not something that we really, really need to use. If there's something new, just try it. Also, be open-minded and try new technologies. Some of them will work perfectly for you. Some of them will not, but at least you'll know how they work. And your job is not just to write the code. Your job is to understand the business needs and to try to empower that with the code. And finally, serverless might be a solution or might not. Just try it. Don't trust me anything. Just try everything in, and see how does that work for you. And finally, one more thing, not that one, is the book. So with my friend Alexander Simovic, I wrote the book for many publications, and it explains how to use serverless from writing a simple API to adding database, adding authentication, everything in serverless way. Then it explains how to build the Alexa skill and some chatbots and things like that. And finally, it tells you how to do everything with how to migrate your production applications and shows you some case studies that are more serious than the case studies that I presented today. You can go to effortlessserverless.com/book, and then you'll see the link to the book. You can follow me on Twitter, and then also there's a promo code that you can use for many books, for any book. There's a 40% of discount for any book today. So that's it. Thank you.
Thank you, Slobodan. Thank you, Slobodan.
I don't think we have, sorry, one more thing. We don't have time for questions, but whoever asked the question on Twitter, I have two free books to give out. So if you ask the question in next like 30 minutes, I'll pick two persons and send you the promo codes for the book.
That's good, because you can ask him questions in middle track. Since this is the last lecture for this PHP Serbia conference this year, all that's left for me is just to invite you to join the rest of the PHP gang in the middle track and enjoy some cold beer, maybe some cold juice, and hopefully I see you next year here. Thank you.
Thanks.